Let's try another one where you are solving for c. Because if we think a squared plus b squared equals c squared, this is my 90-degree angle because I have a tangent and a radius. So this tangent is going to be one of my legs. This radius will be the other leg. Across from that is the longest side. That is c. So what I'm going to do, let's call this one a and this one b. If you do it the other way, it doesn't make a difference. I'm going to take 46.5, put it in for a, 25, put it in for b. Let me do this over here so I've got some more room. So I have substituted my numbers in. I used brackets to do that. Now let's grab a calculator and let's type those things in. And now I can add those two together. And this, the way that I've written it right now, is a super common mistake. What a lot of people will do is they'll get through these steps and they'll maybe forget that that's actually meters squared. They'll just write it as meters. And they'll say, okay, C is 2,787 meters. And they don't look back at this triangle. They just move on to the next question. The reason why you look back at this triangle, and if it helps you to actually write that number here, if that's how you remember, you need to double check afterwards, go for it. The reason why you need to look back is because if this is 46.5 meters and this is 25, then almost 3,000 would be like, what, 30 of my smartboards? That doesn't make any sense. So now I need to go back over to here and think about what did I miss. This was meters squared and meters squared, so that should be meters squared right there. This does not just equal c, it equals c squared. So if I want to solve this the rest of the way, I need to do a square root on both sides because that'll get me to my answer of c right there. When I do that, and this is straight off of my calculator, I get an answer of about 53 meters, and that makes way more sense. So instead of that, 53 meters sounds a whole lot more reasonable there. Let's keep our 2 decimal places, so I'll say that's my final answer. Next one. I'm going to start throwing word questions at you to see how well you really understand this. And now I've already labeled some of these for you. I wouldn't have to do that because that information is all in the question. So let's have a read through it. I say that we have an airplane at vertex A. So what I'm telling you is that right here is my airplane. And there's one wing, and there's the other wing. So that airplane is at vertex A. Ah, that's not what I wanted. Airplane, there it is. Okay, we're right there. Then I tell you that it's at an altitude of 9,000 meters. And that's where this measurement comes from, is because that is 9,000 meters above the surface of the Earth. We're going to assume the Earth is perfectly spherical. I know it isn't, but for this question, we're pretending. Other thing I tell you is that the radius of the Earth is about 6,400 kilometers. So that's where I labeled this. That's this radius right here. What I didn't label for you, and what you can do at this point, is you can say, wait a minute, this is also the radius, So it must also be 6,400 kilometers. Then I tell you that there is somebody on this airplane who sees something over here. This would be the horizon. Because remember, the Earth is something that you can't see through, so this person can't see to this point over here. The furthest they can see is to the horizon right here. And this person is curious, how far away can I see when I'm up 9,000 meters off the Earth? So what we're going to do right now is we are going to use our rules of circle geometry to figure that one out. I have a feeling we are going to need Pythagorean theorem for this one. So I'm going to write that formula down. The reason why I have that feeling is because I have a right angle right here, and I have a side length that I can figure out, and I already said that's the same radius, so it's 6,400 kilometers. It looks to me like if I added these two numbers together, that would give me this whole side length. And if I want to label this triangle as A, B, and C, I have one of my legs is right here, so let's call that A. I have another leg right here, except I don't know how long it is, but that one's going to be B. When I look across from the right angle to the longest side, that is C, and I know what that number is. So I can put this number here in for A, and I can put this number here in for C, and then I can solve for B. So that's the way we're going to go about this one. And if you look back here, I should have put that squared on the outside of those brackets. Let me fix that. Now I can go and I can actually square those numbers. So if I go 6,400 times 6,400, I get a really big number. And remember, I squared this number and I also squared the units. I don't know what B squared is yet. When I go 15,400 squared, I get an even bigger number. And same thing, square your number and your units. What I can do now is solve first for B squared, and then I'll do a square root afterwards. So I have positive 40,960,000 here, kilometers squared. Let's subtract it. And let's also do that on this side. I get that answer right there. And again, super common mistake is to stop when you get there and just go on to the next question. You got to remember though, that's not what B is, that's what B squared is. And if you think about it in terms of this diagram, it makes sense that that number is way too big. So that's your clue to go back. B squared, sorry, if we do square root and square root, we get just B and an answer of that, 14,007. And that makes sense because this is bigger than 6,400 right there, but it has to be smaller than that number because C is always the longest side. So 14,007 kilometers, that makes sense for that one.